Okay, hello everyone. So my name is Imed Ben Elheni. I've been working as a software engineer for almost 1 year, and now I am occupying the role of AI software engineer in InstaDeep. And today talk, I want to share with you some thoughts about unit tests in general. And we are going to run some examples in Python using pytest framework. Although this is in Python and pytest, but I believe that most of unit test talks are applicable to any language or framework. So I want to start with this quote by Harold Abelson in his book Structure and Interpretation of Computer Programs. So Abelson says, programs must be written for people to read and only incidentally for machines to execute. We are excited about writing those instructions and having them computer this machine execute our instruction. It gives you a sense of power, of magic that is software programming. But after that, when you work with people, whether in open source projects, in community, or in companies that are developing software, you are not working alone. You are working with a team or multiple teams of people from different backgrounds, from different levels of knowledge and skills into programming. And so the fact that becomes much more important than writing a code that executes is writing a code that is human readable. And although this is true for all programs in general, I mean, unit tests are a subset of those programs. But I want to argue that I think that for unit testing and the testing code in general, it must be more human readable than the production code. Because the unit tests are how you ensure that, and not only unit tests and that stuff, are what make you sure that the code is doing the thing that it is supposed to do. And I would even say that if you have a very clear test code, even if the code that is running behind is not very clear, or as long as you have this insurance that the code is doing what it is supposed to do, then you have a very good quality product. And also a great advice from the Pragmatic Programmer book. So this by Andrew Hunt and David Thomas. So this is a classical book, and I encourage you, if you didn't read this book before, to read the Pragmatic Programmer. And about testing, what they tell us is test early, test often, and test automatically. So, okay, for test early, we're not talking about test first or not. So there is this test-driven development that is not the subject of our talk today, but it's a very good practice if you do TDD. But the idea, even if you don't do test first, you have to test early during the product development or program development. Don't wait for a release to test, or after you finish a whole program to test. So you have to test early in the process. And you have also to test often. You only benefit from tests when you test often. I mean, in order to have that feedback loop, a short feedback loop, it will help you to detect issues very quick and to iterate quickly on the code. I mean, however clever you are, however smart you are, you can never write it right since the first time, especially if it is a very big application or you are collaborating with many people on that. So the shorter the feedback loop you have, the less cost you have when you miss something or you do something wrong. You only lose, for example, if you test every a couple of minutes, or for example, after an hour, you run the test again. At most, you will lose the work of 1 hour. You can redo from scratch based on that last time you ran the test. And an important fact is to test automatically. I mean, some people may still are not convinced about unit tests, and you may think that, okay, this unit test, I'm writing double code. I know how to write code that doesn't have bugs in it. Why do I have to write unit test? This is a waste of time, and and who tells me that the unit test code is right? Maybe it is wrong. Do I have to write unit test for the unit test? And all that thinking. But I would say that, okay, if you don't use automatic tests, how do you know that your product works as expected? And you must have done your testing in some way or another. You compile, run the application, you enter some input, you have some output, and you are testing basically manually your application. But maybe that works for a very small project or a project that you are doing alone. But in a big code base and with different people collaborating, this is not scalable, this is not sustainable. You must have a way to ensure that even if you know your code and you know that you didn't break anything in your code, you cannot be sure that you didn't break something else in other people's code. So it's really important to have the tests execute automatically, and otherwise, unfortunately, especially for regression, so you do not break existing stuff. Unfortunately, there are still companies especially in legacy systems, that still rely on a very big, relatively number of QA people that do the manual tests every release, and this is not really sustainable, I think. And this is not to say that the automatic test will replace the QA, but what I'm saying is that QA people should do more exploration and more creativity into testing the application, and not execute the manual tests of the regression to detect regression. That is a task that a machine is better suitable to do automatically. And this idea of testing early, test often, test automatically, you will find this in continuous integration. Nowadays, in any continuous integration pipeline, you will have this unit test step in the pipeline, because everyone knows that if you just build, you have a build step, and then you go directly to deploy, then how do you know that you didn't break things? You have to have those tests. So there are many definitions of unit tests or all the other types of tests, but let's agree just on a small definition, at least for the scope of this presentation. So what is a unit test? Let's consider a unit as a small piece of code. We put emphasis on this piece to be small. It can be a method or a function, it can be a class or module, or it can even be a small group of related classes. We don't want to be strict on the exact definition of a unit here, but we say that it must be small. So strictly speaking, it is not a unit test if it uses, for example, the file system, the database, the network, because what we want from a unit test is we want the unit test to succeed or fail based only on the correctness of the test code and the correctness of the piece of code that is being tested, also known as the system under test. We shouldn't depend on other things, because it will make it harder to detect problems and to debug issues when they happen. For example, if you depend on the file system in your test, the file system is not something that is guaranteed. Maybe there are permission issues, maybe it is out of storage space. Same thing for database. the database connection can go down. Anything can happen. Maybe a concurrency with or data was removed from the database. Also for network, it can also be slow or do a timeout. So, and in addition to that, to this correctness issue, these accesses introduce a lot of slowness to the unit tests. And we want the unit test to be fast in order to execute frequently and as much as we want. And here I want to introduce also this testing pyramid from this image is from Martin Fowler blog. So the idea here is that most of the tests that you have in the system should be in the unit tests, because they are both cheap to write. It means it doesn't take a lot of time to write unit test, should be done in a few minutes, and they are very fast to execute. So you should probably be able to execute thousands of unit tests in the matter of few minutes. This is not to say that other types of tests are not useful. You still need some service or application layer. You can call these integration tests or whatever. There are a lot of tests of test names. But also there is the UI test. It means to test the whole system through the user interface. Yeah, just a small note. We're not talking only about graphical user interface. For example, if you are developing a REST API, for example, then the REST methods are that API, testing through that REST API is your user interface test. You should have those tests, but only few of them, because they are very costly to write. They take a lot of time. Maybe you spend few hours to write a UI test, and they are slow to execute. It can take probably thousands of UI tests for your system. So yeah, and just to give, there is no hard rules about this. Yeah, we can say 70% unit test, 20% service, 10% UI. I would say that rather you should judge based on your application, on your different scenarios that you have. But that's the idea. Most of the code, we do not seek for 100% coverage, but most of it should be in the unit test. So hopefully I convinced you by now that unit tests are very important. If you are not already convinced, yeah, and you can find a lot of research about unit tests. Another point that I want to discuss in this presentation is this idea of test doubles. So this diagram is from xunitpatterns.com by Gerard Mezaros. So yeah, you have to think of this double. It's like in the movies when you have a double to the actor. So for hard actions, so this test double will replace the real collaborator during the test. So yeah, because usually this unit test, this small unit that we were speaking about, usually it will be communicating with other pieces of code. It is hard to find a piece of code that is isolated and it is not used anywhere else. Yeah, because that way, how do you have a system, or how can it be useful? In order to be useful, it should be interacting with some other classes. But in order to test that unit, we should introduce this idea of test double for the other units that it collaborates with or interacts with. And we cannot use the real generally the real objects, because that way you need to start the whole application. That's in the scope of end-to-end testing or system testing, not of unit tests. And there are different types of test doubles. So usually in the test frameworks, they call this mock. They give you this helper object or class called mock. So many people will call every test double as mock, but as we will see, mock is just a type of test double. There are other types. There are some differences between the types, and I think it is good to know that there are this difference. So you don't call everything mock. So we have basically the dummy object, the test stub, the test spy, the mock object, and the fake object. There are also other variations on these test doubles, but I think these are most important ones. Okay. So as Linus Torvalds says, talk is cheap, show me the code. So I hope I didn't talk for much. And let us switch to the code. Okay. So here I have an empty project. Yeah, first, in order to install pytest, you just install with pip install pytest, or yeah, you can check the documentation. It's just very easy. It's just module that you install. Here I'm using Conda, and I installed the Conda environment. I installed pytest using. It says that it collected 0 items because simple example. Okay, so I have this classical small program that tests if a year is a leap year. So a year is a leap year if it is divisible by 4, but if it is divisible by 100, it is not. But if it is divisible by 100, by 400 years, then it is a leap year. This is in Gregorian calendar definition. So we want to write a unit test for this. So we have to append the test. To start the test function, test prefix. So yeah, let's just make sure that it runs. So here I'm by test something. You will assert on something and assert accept the Boolean condition, because we have only two states in the unit test. Either it passes or it fails. There is no in-between state. So assert, for example, true. I assert false, it should fail. So like this is just a quick way to verify that my environment is set up to execute my tests. So let's and here what I do is let me import sleep the year 2000. 20. This should be a leap year. Let me run. 20 not be a, so this test still passes. If it make a wrong test code, it will fail. But because my test code is wrong here, not because of the code. And the year 2000 is there because it is divisible by 400, but is not a leap year. So this passes. That I want to say is that if you're not here, we are assessing a lot of things. If fail, for someone changes the code and breaks a condition. So now it says that the test has failed, but if I go to the test code, okay, it has failed, but which condition has failed? It is not clear to see it like that. So it is common in code bases that people just test that a function is, but this is not really meaningful or useful for other people. And they remember that we said that we want tests that are human readable, that are easy for other people. So when something breaks, this test is not very helpful. So yeah, let me return the other one. So what would be a helpful, more helpful way? We can try to take this into and then we have here that is divisible. Like to. So if I run this, I have something that is 100 is not leap. So now the 4 test is passed. Now if I break, for example, this condition, this code, if I go back to my tests, which case has failed. So now it's 100 is not leap because we failed this case. So I know this is an example that we can follow. That form will be better statements. I want to write very less. But remember that this is test code, and being human readable is more important. I wouldn't use method names for code, but for test code, if it also other patterns for naming the functions like when something then result, etc. Get the idea. The idea is to have something more meaningful and have more granularity. If something fails, so it's the method for it. On the contrary, most of the cases, if you want to treat each scenario by itself, you will find yourself writing more test methods than the test method that you are testing. Okay, another point that I want to add is that here there is something that is not really true about these sentences, and a year that is test cases, the sentence is correct. I didn't fix this. Let's fix it. Okay, so now everything is good. And also notice here that I was testing these are more ideas about having a code that is human readable. This is not just to give you example of pytest unit test. You can find a lot of examples, but the idea I want to focus more is give something that is human readable, and don't be afraid of writing very long names for tests if they are clear. So and note also here that when you choose values for test, try to make it easy for the other people to read. For example, it is clear here when you read 2020, 2021 that this is a year. 16, 100, and 400. But when someone looks at your code, it's not really clear what is 3 or 16. It doesn't jump directly to the mind that this is a year. It is hard to see this as a year. Although this still passes the test, it is hard to see this as a year. You will tell me, okay, we need to test corner cases. I mean, okay, you're right. Here to test on 2021, but also to test on 3 or 19. It's okay. You see the difference here. Also 20, even if you want 24, etc. So this still passes, but you have to always give something that I want to show you in case you have many cases to assert. You want to test on multiple values, but for the same test condition. I have something that is called parameterized tests. So you will just have pytest mark. You will need to give the value of the and then you give it now I can just say here and I have to import, so it will run, but for this, because we're using a decorator from pytest, we need the import pytest. So now when I run this, it will execute, but now you see here 6 instead of 4, because this one will be executed 3 times, each time with a different value. Okay, so a test table and you want to run on multiple values, it will be shorter and cleaner to more concise form to do that.
Guys, we're running into a little bit of connection issues, so we're so sorry about that. I think we're just overrunning the internet with every single DevFest running the same weekend. So please be patient. Ahmed will be right back. Thank you.
Hello, sorry for the connection issue. So, yeah. Where we were with pytest. And like here you see the some case you, as you can see. Equals equals. Failed this test. Tell me that this okay for now it's here the line where it failed. The scenario not be easy with which line. Okay, I'll use parameter for every or two cases later, but whenever you find it suitable, it's a cool feature, nice feature from pytest to have these parameterized tests. And there are tests every other framework for even for other languages like JUnit, XUnit. JUnit for Java, XUnit for C. Parameterized this now what grab an example of a phone book. Okay, simple one. So let's have also want to wrap the key the behaviors behave differently for different behavior.
Hello again, guys. So sorry about this. Like I said on Twitter, I think that all the GDGs running their DFS at the same time is just really causing issues with internet connections. So we're trying to get Ahmed back online. If that is not possible, we'll try to do a recorded version or to reschedule this at a later date. Again, apologies. It's just something that happens sometimes with live streams, sadly. Um, Let us know in the comments if there's any specific thing you would like to see, and follow us on Twitter and on Facebook to see where we're at and what's coming next. We're still trying to get Ahmed back online. Like I said, you know, internet. There he is. Hopefully this time, third time's the charm. Let's try it again. Ahmed, can you hear us?
Yes, I can hear you. I think
Oh,
my ADSL connection is not stable today. Maybe I will
y-
switch to phone connection, but hopefully no one will call me.
okay. If there are any issues, Ahmed will be absolutely okay with doing a taping and just posting it online at a later date if your connection does not hold up. Okay, so let's try 4G. If that doesn't work, we'll record for a later date. Okay, no worries. It happens with live streams. C'est les aléas. So yeah, let's see if this. Right now, your connection seems to be stable. If you
Okay,
could try
so sorry for the
to
inconvenience. Yeah,
It's totally fine. It's totally fine. It happens a lot, surprisingly. But if you could try to share your screen, we could see if it works this time around. I can hear you.
yeah. Okay, now I'm on 4G.
That's a lot better. Okay,
Yeah.
cool. Let me just
Okay.
remove the old you from. There we go. Awesome. I'm gonna mute myself. Go back to it, Amit.
Okay. Okay. So we were at so we have this phone book that looks up few numbers in the phone book, and in the phone book test we are asserting on getting that exception, because you cannot just get the exception as a result and assert on it. So we're using this pytest raises, and we check that okay, if the code doesn't raise an exception, for example here, if it just returns without raising an exception, if I run the test here, it will fail because it is expecting and it says did not raise. It did not raise an entry not found. Also, if I do not raise entry not found, I raise another exception, it also fails because it received a key error, not an entry not found. So yeah, let me go back to fixing it. And you can see now that now the test is passing. So that's about the use of pytest raises. Now let's assert on some value that we add. So test existing entry returns phone number. So I will create the phone book again. And I will add an entry to my phone book. So let's call this Bob, and the number is 1, 2, 3, 4, 5. And I will get the number here as phone book dot lookup Bob, and now I will assert that number is 1, 2, 3, 4, 5. Let me run this test, and the test succeeds. If I just change this to another value to make sure that it will fail for the right reason, now it is failing, and it tells me that expected was this value and the actual is this value. So, and notice here that we are using two methods. I'm not testing add, only add, and then only look. I'm testing a behavior. I mean, the behavior of the phone book when you add you add an entry and then you look up for that entry. So there is a subtle difference here. I mean, don't try to strictly test only that method alone. Try to test through the unit that you are testing. I mean, we may try to be strict. For example, here self.numbers, I will try do in my test. Okay, I add here, but then I will, but then I will do what? Yeah. For example, I will assert on phone book dot numbers here. Because okay, there is nothing as private attribute or field in Python. You can access these. We just add the underscore to give as a hint that, okay, this is private. You should not mess up with this. And although you can do this and assert on those phone numbers, this is not a good idea. You should test through the interface of your method. So although this is running, this is not a very good idea. You should not try to access the private fields, because this will make the test depend on the implementation of the phone book. What you want to use is to just test through the interface. So, like here, the interface of a phone book for us here is the lookup and the add function and the clear function. That's the interface. There is not really interface in Python. There is this idea of protocol, but you get the idea. Test through the methods that also the code, the users of this class will be using. So the test code should reflect how this, it will represent kind of examples of how to use your code. And notice here that we separate three parts of the test. Maybe most of you already know that, but just to remind that you have this arrange, act, assert structure. So just a quick note about this is that you have three parts. Usually you arrange, then you act, then you assert. You can also call this the precondition. This is the also action, and this is the post condition. You can have many terms for this. This is like given when you do something, then you have some result. But this more maybe related to behavior-driven development. So let's stick with the name arrange, act, assert. It's the main idea. But sometimes in the code, I see people writing those commands, arrange, act, assert. I mean, you can have those to explain in the examples or in the tutorials, but then you don't need to clutter the whole code base with arrange, act, assert command. It's those three commands in the whole testing code. It should be clear when you know the idea of self-documenting code. It should be clear that you have three parts in the test. If you are having a test that is 100 lines of code long, then something else is wrong with the test. Or you have a very long list of assert, or you have to command that, then maybe you should try to refactor the test. Because remember, test should be human readable. It's as important to make the test code clean and easy to read as it is important for also the production code. Also, sometimes if there is really no strict rules about this. I found it personally that if you add just a new line to separate the section, it will be easy. And also sometimes, even if it is a very simple assert, I can just do this directly. Although sometimes it's preferable to keep these separate. But the idea is to just keep something that is easy to read for your people. And also try to remove redundancy. So, for example, let's add another test here. Test adding entry multiple times returns number of last entry. So for example, if I add now to Bob two different numbers, then the second, I should get the last one. So this is a different behavior. That's why I put this into a different test. You see here that I get that value. If I make this fail, this is wrong, this is not the first, it should be the second. But imagine that you are having many cases like this in your test, and you start having a lot of redundancy. So something that is helpful, even with production code, you should always try to refactor to remove the redundancy. So here we have okay. If you create a phone book like this as a variable, you may say, this can be a problem because this is like a global variable, and it can be shared between the different pieces of code. So this is not a good idea. And the data for each test should be separate. So how to keep this data separate without messing without having the test mess which each other's tests. So we have in pytest this tool or utility, which is the fixture, and I will create here a pytest fixture. And what's a pytest fixture? I call it a phone book here. It will just return a new phone book for me here. So here, you just need to pass this as a parameter to pytest. And pytest will know when you give it as an argument here, phone book, it should match the same function name. It will know with this pytest fixture that it's kind of dependency injection. It will inject that into this calls to the test methods. And as you can see here, imagine for this case, okay, this was just a simple call to the constructor, but imagine that you have a class that in order to instantiate, you need 10 lines of code. So you don't want to repeat those in many places. Better use a fixture for that. So here, okay. Okay, let's try to run this now with the fixture. So as you can see here, we have 3 tests that have passed, and each time it executes the test, it is starting with a fresh copy of the phone book. Yeah, what do I want to say else? Yeah, and yeah, please also respect, try to have only one assertion or one logical assertion per test, and do not do something and then assert. So for example, maybe here, instead of having two tests, you will, okay, look at Bob, and then you want to insert it again, add, you want to add a new phone number, and then you test again on that phone number. And you think, okay, I did two tests in one test. This is better. Or also for the same thing, this is not a good idea, because if it fails, you don't know which part of the test fails, and also it makes it harder to follow for other people, because okay, I have a range, I have act, now I am asserting on this, but now I have another a range and another act and another assertion, or it is this an act. If you have multiple assets, then do another action. It makes it harder to follow. If you keep the assertion is the last thing, and you only do the asset, that's better. If you need to assert on different thing, you can do a different test for it. And yeah, the fixture will be different. Also, you can have different fixtures. For example, here, I can have another fixture. I can give it another name. Let's call this pre-filled phone book, for example. And this pre-filled phone book, imagine that you want to instantiate a list of data, and you don't want to do this for every test. So this will have already pre-filled phone numbers, Bob and Alice, and you return that phone book. Here you can use, instead of using the phone book and have to add that entry, you can use the pre-filled. Remember, you have to use the name that you declared here in the fixture, a pre-filled phone book. So if I run this test, it should be I changed the number 1, 2, 3, 4, 5, 6 when using the pre-filled. Let me use the same number so it doesn't crash. Okay. Something went wrong with my demo. Number from lookup function object has no attribute lookup. Sorry, because I have to use this name. Sorry about it. Yeah. Now it is running. Even here, I can use the pre-filled phone book, and you only add another time. But here, okay. To overwrite pre-filled phone book, pre-filled phone book. This will still run, but I think this makes it maybe a little harder. It depends on the case. Because this is, when you look at this, you see, okay, I add this value and I get this value. It looks kind of similar to the other one. Maybe for this case, if we keep those two values, it is clear that the idea to show the reader of the code, the idea that you are adding to the same value multiple times. Yeah, that's another point about readability. So, I think this is what I wanted to show you generally on about pytest. So what we've seen so far is to run tests with pytest. Okay, let's just do a quick resume. So you install pytest, then when you run it, it will run. Okay, let me fix the last one because yeah, I'm using phone book here. It will detect. So here it starts by collecting the items. So it collected the files that has this suffix test, and then inside of those files, it will look to methods that functions that start with test underscore, and it will execute those. Also, we look at how to do a parameterized test. If you have like a table of data that you want to check, you can even put the expected value and run the tests. We checked how to write meaningful test names and also with trying with the human readable values. And we also checked how to assert on an exception with pytest.raises. And we checked how to avoid redundancy, use reusability with pytest fixtures, and we can also have multiple different fixtures. And yeah, you have to use the same name for the fixture. So now I think it's time, if everything is clear, to see. Yeah. Now it's time to start with talking about the test doubles. So let's start with the dummy object. Remember this diagram from a little before. So we said that we have dummy object, test tab, test spy, mock object, and fake object. Okay, I'll try to be a little quick. We lost a few time with the connectivity issue. But let's try to cover these, as I think it is important. And it's not very difficult. It's just simple stuff. So the dummy object, when do you use this? When neither the test nor the system under test care about this. Maybe you have a parameter that you need to pass to the system under test, but just to instantiate it or to create it. But you don't care for the current test that you are writing about that. So basically, it is nothing. It is not used and can be as simple as a null reference or null object. So let's try to, yeah, for this I prepared a small example I can show you quickly, and where we will add these test doubles. And bear with me a minute. Okay. So let's say we have an alarm. Yeah, we have small application that will have an alarm that can be turned on and off. And we have a sensor, a temperature sensor, for example, here, that when we ask it to give us a temperature, it will give us a temperature reading. And the idea is to have this alarm switched on and or off depending on the data it collects from the sensor. Maybe this is useful for some IoT application or whatever. And we created a small main to run this alarm application. We also have a small configuration for this. So we have a minimum threshold, maximum threshold, outside of which the alarm will go on. Okay, how many times to run the application, and yeah, what is the period? So it means here in seconds, this is the period, how much. I will just show you how to run this. Okay. So if I run Python main. I will add the log level of debug, and yeah, I will show here in the main, because I have some parameters that I'm getting from the command line. So this is log level, and this is AB is minimum maximum threshold. So let's say that minimum is 20 degrees and maximum is 50 degrees. Outside of this threshold, we should turn on the alarm. When I run this application, I have debug information that alarm started, and then I'm using a random sensor here, so it's giving me random values. But yeah, imagine that this sensor that we have, maybe you connect through the network to reach this sensor, or it is costly to execute this sensor during the test, or it is not accessible during the test code. Maybe you need to have a setup of IoT and devices to be able to execute the real sensor. So just for the purpose of this demo, I'm using just a dummy implementation of sensor. So the goal here is to test the alarm. But as you can see, the alarm depends on the sensor. And it depends also on the configuration. It depends also on the logger that I'm using to log the information here. So it already collaborates with other classes. If I open the sensor, the alarm class, you see it uses the sensor in different places. It also uses the logger. So how to test this code? Yeah, if we were to do an end-to-end test, it will be costly. We will have to parse maybe the output of the application and to test it against some values, and how to do with these random values, how to test these random values, how to control this, etc. Also, the application will generate, let me stop it. It will generate also a log file here. It will write to a log file. Do we want that every time? Remember, we execute the unit test frequently, so it will generate a log file each time. And it generates also CSV file here with the values of the temperature. So this is simple example, but try to make it a little more interesting with some features from production code, like you may have logging to files, you may have exporting to some data files like CSV. Yeah, and for this, you have time.sleep, so it sleeps here, and you don't want in your test to use a sleep in your test because it will make the test slow. So the idea here, yeah, for alarm test. First, in order to be able to test the alarm, hopefully the example is not very complicated. You can follow along, but yeah, let's just test that. Here, I'm copying this. The alarm is off by default. So here, in order to instantiate the alarm, I need to give it a logger. And also I need to give it a sensor. And I will assert that it is not on. Alarm is not on. Yeah, what is a sensor? Okay, I cannot run this example with only the dummy logger without giving it a sensor, or maybe I can. Okay, let me try. Let me try. So what is the test configuration? The test configuration will be just a fixture. Remember, we've seen the fixture. So import pytest, import pytest, import configuration. So this is the test configuration. So threshold is like between 0 to 100, and the run limit is 1. So if you execute run, it will run execute only one time, and the state period is 0. So already we have a different test configuration for the test. This is useful. I mean, do not depend on hard-coded values. So here, if I go to the alarm, you see that I depend on the config. This will allow me, for example, for this running If for production, maybe the run limit will be infinity. But for the test, I can set this run limit to 1. So this loop will only execute once. And also, the time.sleep will not execute in the test because I give it a state period of 0. So it will run one time without sleeping. So you can have this idea of this something configurable. And yeah, you may tell me, okay, you are changing the production code to make it testable. And yeah, it happens a lot that you need to change your code to make it testable and to have points where a point of control of your code. But it's not here. It doesn't know about the test. We changed it, but this is like more about a configuration. It can be useful not only for test, but also for to make something configurable in general. Yes, so let's go back to the test. Phone book test. No, not phone book test. Alarm test. Yeah, maybe I can give it a nil sensor, non-sensor for now, and but I will not poll anything. Okay, and I will not give it a dummy logger. Let's try like this. Let's give it none, the alarm. Give it none for logger and none for sensor. So here, if I try to run this test, it will fail. Why it fails? Because it is okay, not self. Sorry. It will fail. Why? Because when it wants to execute logger.debug alarm started, right? Here, when we create an alarm, it logs the alarm.started. But I'm not interested in testing the logger. This is just for the execution, for debugging later. So here comes the idea of a dummy logger. So I will create here a pytest fixture, and I will call this dummy logger. And okay, for this dummy logger, I cannot pass none. You see, in this case, maybe in other cases I can pass none, but I cannot pass none here for the dummy logger because it will call the functions in it. I may create an object that contains the methods of the logger, but there is an efficient way to do this using create autospec. Create autospec. This is a tool from unit test mock, and you will find here create autospec. So I will tell it, okay, create autospec for logger. And it doesn't know logger, so from logging import logger. I will miss an underscore here. This create autospec will automatically create dummy methods for the methods that are found inside logger. But I don't care about the setup of those methods or what they do. I just want when I execute. So let me add dummy logger here, the fixture that we added. So now if I pass dummy logger, now if I run, it should pass. So when it reaches here, it will call the dummy logger, but neither the test code nor the tested code care about this dummy logger. Now let's go back to the test tab, which is more interesting. So now a test tab is to control the indirect inputs to the system under test. So for example, what we did here in the phone book test or the leap year test, we are putting we are giving the test class, the tested system, direct inputs. So I am passing the inputs directly from the method that I am calling, whether it is add or lookup. In this case, I need indirect inputs from the sensor. The alarm depends on the sensor and will get the data from the sensor. So if I do poll sensor, it will get the data from the sensor. And I have this, this logic of getting 3 times the value, and where only raise the alarm when the value is for 3 times successive times outside of the range. Okay. So this stub, it contains nothing except what you put there. So I can finish this to show you how we can test that logic of 3 times consecutive temperature. So for this, alarm is off by default. So here we didn't test. Now I need to give it a stub sensor. You don't need to call this dummy or stub or anything. You can give it any name you want. I'm just using here stub to make sure that it is clear that it is stub. You can give it any name you want. So here I need to use the stub sensor, and for this stub sensor, we'll create also another fixture, and here we will use unit test mock. So we'll create a mock, and the idea of a mock is that you can. So this is a stub. That's the idea I talked to you about. In the test framework, it is called mock. It's the object that you use, but you can use it in different ways. In this case, we are using the mock as a stub. So the stub, you give it the input that you want. So it only contains the input you want. So for example, if I say return, you give it the name of the method, get temperature, and then the return value, it should be 1 here, and return that stub. So I'm going to call the sensor 3 times, then assert alarm is off, not alarm is on. When I run this, it succeeds. So if I want to test with a different value, let's just copy this and say test that the alarm is on when the temperature is more than max threshold. You remember the long method name. Alarm is on when temperature exceeds max threshold. For this, I can create a different stub. For example, here for the sensor, sensor normal, and then another sensor will be sensor high temperature with a temperature of 200, etc. But there is also another feature that I want to show you in pytest, which is pytest markers. So here I'll just copy this. In the stub sensor, you see you can have a request argument in your fixture, and in order to use that request, I can say, okay, this I want to get a marker, and the marker name is temperature, and I want to get the closest marker with name temperature. If that marker is found, I get the first argument. Otherwise, I will give a temperature of 20 by default. So by adding that, I can still run the default one. It doesn't fail. But what is this marker? This marker is just, you say, pytest dot mark dot temperature 101, because the default limit is 100. So let's give it 101. Now, if I run this, it fails because it expects to be false, but it is true, because now we have a high temperature, so this condition is wrong. I should assert that the alarm is on now. Now when I run it succeeds. And if I run both, I have here both tests. Also, it is better to have the test names, because in the report of the unit test, you will find some English sentences, things that other people will understand. So with this marker, you will, it is a nice feature. You can have custom marker. Instead of creating multiple fixtures, it's like having a parameterized fixture here. And it is very generic. You can have multiple arguments added to this. You can add more arguments here, etc. So it's a really useful feature to avoid, again, redundancy and writing the same code many times. So that's the idea. We can also have this, okay, let me just copy this. Another test for the low, minimum below the threshold. I don't want to combine this because as usual, in my case, it's always to your judgment, but in my case, I want to differentiate when it fails for max from the case when it fails for minimum threshold. So I give it -1 here. I believe this will still pass. Okay, I have an issue on this wrongly. Yeah, it passes. You can run all the tests, and you see these tests. I mean, they are very quick. They are even put as 0 millisecond because you don't access databases. And if I was instantiating the logger, it will take at least I don't know, maybe a few milliseconds to write to the log file. I'm not using a log file with this dummy logger, and I am not using a real sensor. Or if we imagine that we have a sensor that you access on your IoT system with network or something, I'm using a step sensor. And I am testing the logic of the alarm, if it is high, if it is low, etc. So that's the idea of a stub. For a spy, it tests the indirect outputs of the SUT, of the system under test, and you can consider it as a test stub with recording capability. So in addition to you put the indirect inputs of the spy, you also want to verify what were the outputs of the spy that were passed to that spy. And so you validate those expectations afterwards, after you call this your code. So, for example, if if I want to do, okay, let's try to assert. Sorry, let me go back to the code. For example, here you see when I run the alarm, I use a capture here that will capture this to the capture that we have here. It will capture to a CSV file. And as usual, I want to assert that, okay, I am calling this capture method of the capture, this sensor data capture, but I don't want to write to a file to not make the test slow, etc. So let's try to do the capture. So let's assert that this sensor data is captured when the alarm is running, right? So let me create an alarm. And here I want to also give it my spy capture. So, okay, I'm just copying this to make it quick. So here the idea is to use magic mock from. Why do we use magic mock? Because in the capture here, we have these magic methods, the enter and the exit, that will open the file and exit the file. For me, I don't want to do anything for that, but you need to have those magic methods. Otherwise, the test will fail when it tries to execute with capture. If we give it a normal mock, it will fail in this statement, because when using with, you need that magic enter. Yeah. So, okay. When enter, I don't want to create a file, just give me the same value, because for the real one, it should return self here. So here in the mock, I'm just saying, okay, when you enter, just return me this spy capture. So how to now I will pass this spy capture as a fourth parameter to alarm, and this is another technique also to be able to test this class. I'm adding a default parameter. So if you don't give me a capture, so this is the test code will give you a capture, but maybe the existing code doesn't give you a capture. So by default, it will return the sensor data capture that uses the file, etc. But in the test, I specify the capture to avoid instantiating that heavy, or slow data capture that writes to a CSV file. So yeah, at least let's finish with this. Time is running. So here I just need, we say that, okay, so we execute the code, so we need to execute it. Let's say .run, and then, and in the test run test configuration, we specified that it will run only once. So we can here assert that the method capture of spy capture, we can assert that it was called once. Now, if I run this test, now I'm having another issue. Okay, I don't know what's the issue. Maybe I just commented. Still. Sorry, I'm sorry. What is the issue? I just forgot to put these the fixture as parameter. Oh, sorry. So we say that capture.capture.assert called once. Here you see that the test is passing. I will just show you that if I remove the call to capture, if I don't capture here, I'm commenting that. If I rerun the test here, the test will fail because it is expecting to have been called once, but it was called 0 times. So you have this capability in the spy to verify that it was called and how many times it was called. You can also explore that it can be called with with which arguments it was called. The mock object is similar to the spy, but it is different in the way that it tests the indirect outputs and validates them as they are exercised. So you set up the expectation before you execute the code, and it will fail the test if not called properly. Like the spy, the difference is that it will not let the test, the execution continue. If you use the mock object in a bad way, it will fail the test. And the fake object, you use it when the real dependent on component is not available or too slow or cannot be used. The difference is a fake object is not just a dummy, stupid functions or objects. It has an implementation with logic and behavior. But usually the implementation is much simpler than the real one. A good example for a fake object will be, for example, an in-memory database. So you replace the database with an in-memory one, which is much simpler, but it already has an implementation in it. And it makes your tests faster and easier to run. We are out of time. I wanted to show you a fake sensor example, but yeah, to test that 3 successive time behavior and instead of the random behavior. But that's it. Thank you. Hopefully you learned something new today, and I don't know if we have room for a few questions. Thank you everyone for your attendance.